Hello and welcome to our Gotham Television. What do we call our show? Gotham Live from Gotham?
Sound TV.
Gotham Sound TV? We should really come up with a better name. I am here with Dave Missall. I've asked Dave for your business card because you have a long title. We've known each other for a long time.
We have known each other for a long time.
But your title is Manager, Customer Development and Applications Engineering for the Americas.
Yes, it's a very long title. Yes, it took a long time to figure out what we're going to call me.
I think that's cool, and I'm really happy you're here.
Yeah, thanks for having me.
You're here to talk about the Sennheiser Digital 6000 series of wireless.
Yes. And, I brought the 6000 receiver and a couple of transmitters and some accessories that we can go through.
Cool. What are we looking at?
Well, it's this is our latest offering for a digital modulated transmission for wireless microphones, and it's an offshoot of our D9000 system, if you're familiar with that, Peter, which is our 8-channel rack frame D9000 system. We wanted to make something that was a little bit more portable and in a 2-channel chassis as opposed to the 9-channel chassis, and we got a lot of feedback from the rental companies that wanted something where they can configure 2- and 4-channel systems a little bit easier. Right. So we developed the 6000 series, and then partnering it with a couple of different transmitters, and then I'll go through some of the capsules as well.
So is this cross-compatible with the 9000, or is it its own modulation?
Well, actually, it's sharing a modulation scheme that the D9000 has. When you look at the D9000 system, it has 2 modulation schemes. One is called HD mode, or high definition mode, and where we have an A to D in the transmitter, and we modulate it with any compression, and we're not throwing out any data at all. So it's as clean as you can get to a wired microphone. And then we also have an LR mode in the D9000 system where we're doing a PSK type of modulation scheme, and we're throwing some data out, but still have a very good audio quality. So we have 2 different modes in the D9000 system that allows us to have 2 different transmit powers as well. Huh. So when we went to the 6000, we wanted to keep it just in LR mode. So you don't have the HD mode in the D9000. I'm sorry, in the 6000. In the 6000, you only have the LR mode.
Got it.
That's the main difference, plus the channel count with the rack of 8 channels in the D9000, only 2 channels in the 6000. So I can, if I wanted to, take a 6000 belt pack or handheld transmitter and in the LR mode, transmit it to a D9000 rack.
Great. All right.
So the belt pack transmitter is the same size as the 9000 series system. We changed it a little bit. It's all black, and if you remember the 9000 series, it has a silver frame to it. The LEMO connector is still in place, and then the LEMO for the antenna as well. We're doing an A to D in the transmitter. That's 24-bit 96 kilohertz. And then modulating that carrier frequency and transmitting to the receiver. The belt pack has a removable battery. It's a lithium-ion battery that is rechargeable in about 2 hours, and then you get about 6.5 hours of battery life on the belt pack transmitter. If you look at the handheld, which also has a rechargeable battery, and I'll pop this one out as well. Right, slides out. This one you get 5.5 hours of battery life on.
Wow. Okay,
lithium ion. We do have a battery sled that takes regular double A's for both of them. But if you go in with the double A's, then you probably get 1.5 hours to 2 hours of battery life.
Just an emergency backup.
Exactly. It really these are power hungry. You know, as you go to a digital modulation scheme, there's a lot going on in the belt pack transmitters, so it's drawing a lot more power. And when you design a wireless system digitally, you know, we wanted to make sure we had a really good audio quality. So in order to do that, we had to have a very complicated modulation scheme. And that pulls some power, so we had to go to the lithium-ion batteries.
Sure, yeah. Speaking of which, of output power, what is the RF output power on this transmitter?
On the LR mode, it's a 30 milliwatt output power. Okay, and on the HD for our D9000 system, when we do the HD or the the high definition transmit power, that's a lower RF transmit power of 10 milliwatt power. So in the LR mode, you typically get a little bit more range than we do in our HD mode. And we found that most people were running it in LR mode, and that's why we wanted to stay in LR mode with the 6000 series.
Got it. And of course, we'll take this opportunity to talk about power, output power, RF power in a digital modulation scheme is not necessarily the equivalent to the analog.
No, that's a good point. It's different. When we relate this to an analog transmission output power, we relate it to more of a 50 to 75 milliwatt output power when we relate 30 milliwatt to it.
Right.
And in the walk test that we have done, and we compare it with our SK5212, which is a 50 milliwatt output power, it walks the same, if not more, in terms of distance, even though you would think, oh, it's only got a smaller output power.
Right.
What must my range going to be? Because of the error correction and because of the predictive bit management that we do, you can walk further than you can with an analog transmitter, even an analog transmitter at a higher output level.
Right.
It's really pretty interesting.
Yeah.
So this is the bell pack transmitter, and I'll plug in one of the lavaliers that we have for it. And this lavalier that I plugged into it, of course, the transmitter works with our MKE2 lavalier and our 104s. And then also I have the MKE1 lavalier, which is our tiniest lav. That's also available for the bell pack transmitter. And I think you guys are familiar with this one. We've been making it for a while.
It's a great one.
Yeah, it's really resistive to moisture. And it took them a long time to develop it.
And I
really
find
well.
Clothing noise too.
Yes,
it's really resistant.
a little bit less than what you usually see. Yeah. It took them about 3-4 years to develop it, and it was really creating something under a microscope because it's so tiny. Yeah. But they did a really nice job on it, and of course it works with the SK9000 bell pack transmitter. So I'll put this up here. All right. The handheld, it's the same shape and design as the D9000, only now we went with a flat black color to it. And as I mentioned, the battery that slides out of it. This is the antenna on the bottom, sticking out, but it gets protected once you put it in, so there's not an easy way to hit it or bang it. And then it is a removable head for the capsule, and we have a plethora of capsules that's available for the handheld, including, if you remember, on our EM9046, we always had 5004s and 5005s. On the 9000 series, we have 9005s, which are condenser microphones. And maybe we can get a close-up of the condenser microphones that are available in the suspension mount that it shows here. Wow. You can see the capsule is just hovering on this. See if I can get a picture of it. Hovering on the suspension, and just a tiny little condenser on there. And what it does is it eliminates any handling noise on the handheld itself. So when I compare this SKM 9000 and the 6000 in my hand with our SKM 5200, the handling noise is non-existent on the 6000. It's a big difference because of that suspension that they put the capsule on. Pretty cool design.
Yeah.
We also have our 935s available for it, and the 965 capsule as well, and the Neumann capsule. Actually, let me pull that one. Sorry to reach.
No.
We have the Neumann 205 capsule as well. A lot of people like the Neumann mics for stage use.
Sure.
So we have the 204 and the 205, a cardioid and a hypercardioid condenser capsule that's available for this as well. All right.
And in terms of where this fits in overall, so the 9000 at the top, 6000 here, and then 3000, 5000 series?
Right, then you would look at the 3 and 5000 series that everybody's familiar with, the 3732 receiver, SK5212 and SKM5200, and then down to the 2000 series system,
right.
And then you get down to the G3 series system. So when you look in terms of RF performance, when you start comparing between the 6000 digital system and the EM3732, when we look at the 3732, we typically think about 8 channels or 9 channels within a TV channel that we can run. And they have very great selectivity, and they've been industry standard for broadcast and for Broadway for a long time.
This is the 3000,
This is the 3000, 5000 series.
Yeah.
When we look at the 6000, now because of what we've done with the transmitter in eliminating intermodulation between the transmitters, we can now fit up to 15 or close to 17 channels per 6 megahertz wide bandwidth. So it's a lot more frequency efficiency when we look at the difference between the 6000 and our standard 3 and 5K analog systems.
Which, of course, with the coming spectrum crunch is going to be a big deal.
Right.
It's a big deal.
Right. We do 2 things to accomplish that. You know, we want to make sure we can fit as many as we can into a small area, and at the same time keep the audio quality where it needs to be, and also get the range that we still want.
Sure.
So in order to do that, we built a lot of linearity into our transmitters themselves. I mentioned before that we're doing this digital modulation scheme, which needs more battery power. That's actually a good thing, because now I can build in higher linear components in my transmitters so that when they do come into contact with each other, they don't create intermodulation. And we all know that when we put 2 transmitters together like this, they can create 3rd order and 5th order transmissions that can become interference for other transmitters that we have in the area.
Right.
So we built in a higher linearity in the components, plus we put an isolator on the output stage of the transmitter, so it suppresses intermodulation as well. And we only did an 88 megahertz wide bandwidth in the transmitter. We could have went 180 and done the whole UHF range, but we would have opened it up more to having intermodulation.
Right.
So by using the isolator and then having a higher linear components, we're able to totally eliminate the intermodulation.
So 88 megahertz band splits in
Yep.
the transmitter. How about the receiver?
And the receiver covers the whole UHF range.
470 to
470 up to 698, which will of course be 608
Right.
as we look into what's happening with the FCC in the next couple of years.
Sure.
Yep. So I've done a couple of tests with these where I've actually put 32 transmitters, bell pack transmitters, on a table in equal distance spacing. Right. So I didn't do a coordination. I just put them in a row.
0.1, 0.2, 0.3,
Yep.
whatever it is.
Right in a row I think I did 500 kilohertz spacing. So it was like 500, 500.5, you know,
Right.
501,
Sure.
and did a spectrum analysis of it and looked at all the different carrier frequencies, and there was no intermodulation on any of them. It's really interesting to see. Where usually with an analog, if you did that, even if you had 8 channels of an analog system, you'd see all these spikes and
Yeah.
stuff and jumping around.
It looked pretty gnarly.
Yeah.
That's fantastic. All right, so I know about the transmitters, thank you. Tell me about this receiver. There's all kinds of connections going on the back.
Yeah, so maybe we should turn it around and take a look. So
Yeah.
it's your typical 2-channel 1U system. And if we flip it around, let's see if I can do this backwards. Okay, so you have your 2 antenna inputs here.
Yep.
And then you have a loop through. And this is what we've done with the 3732 and the 2000 series. So that's pretty typical.
And is that a passive loop through, or
No,
is there some gain?
it's
on that?
active, right? Because
okay.
we are doing a split there, so we want to make sure that we're not losing that 3.5 dB of loss. So
Right.
we have an amplifier in there so that we can then daisy chain it to the next dual channel receiver and go down to 8 receivers in a row. So I can do
8 dual receivers.
8 dual receivers.
Wow.
So I can do 16 channels off of 2 antennas and loop it through. And actually I could probably do up to 20. Sennheiser tends to be very safe, conservative when it comes to RF.
It's a good position to take.
It is. But we tend to push the limits when we're out in the field. So we've done 20 before, so it works out pretty well.
All right. So that's good for RF distribution, and of course it's BNCs, so I can hook up any remote antennas or distributed antenna system if I had to.
Exactly. You can do a zone, a system if you want to, or any existing antenna system you have out there. If you want to add filters, in line as well, as long as your bandwidth is following what your rack of receivers is, and it can work out very well.
Does Sennheiser sell 88 megahertz filters, or?
We don't sell the 88 megahertz filters. The filtering really takes place in the receiver. If you remember the D9000, what was interesting with the D9000 system is that we had external boosters that had 8 different filters in it that you could user select, or you could user select to the filter group you wanted to use. We've taken that approach and put the filters within the receiver. So when I switch to a new frequency, it selects the filter automatically.
Per receiver.
Yeah, per receiver. Right.
And there's 2 of them in the rack.
Right. So I could be down in 470 megahertz here.
Wow.
With a filter bringing in that RF, and then I could be up in 560 megahertz, and they're on 2 discrete filters isolating all the interference.
Fantastic.
Yeah, it's really amazing. The sensitivity of this is greater than 100 dB on it, and rejection as well. So it's really amazing how it locks onto a receiver. And that's not even talking about error correction yet. Just the suppression of RF noise and interference is amazing. Very highly sensitive system.
All right. One thing, and I'm sorry to jump back to transmitters,
it's okay.
but I don't see a plug-on here.
We don't have a plug-on right now. There's talk about it, but I don't have a timeline of when that will happen. We get a lot of requests for it, and I think that with our EK6042, our portable system, obviously, that can also do LR mode reception, we want to have a plug-on available too with the 6000, but not yet.
Okay.
Not yet.
All right. Now we're still stuck in RF land, so let's move a little bit along on the receiver.
So then we come over to, I'm going to see if I'm looking through. My analogs,
Yeah.
right? Typical outputs, and then with a 1/4 inch as well in parallel. Then we come over to our word clock sync, so you can sync it to an external source or use it as a master if you want.
Because you have digital out, AS3.
That's right. Right, exactly. And then AS3 coming out. We have the Ethernet connection for our WSM software, so we have network
For control.
and you
Telemetry
can do scans and set up the receiver, set up transmit parameters as well, and then you come over to the Ethernet port. The Dante port now that we have available as an option on the receiver.
That's fantastic.
Yeah.
Will this talk to the transmitters?
There is not a back channel, like a Wi-Fi transmission or a separate transmission that goes back to the transmitter. So any changes that you want to do to the transmitter will be done still through the infrared diode
port
that we have in the front.
Okay,
Yep.
fair enough.
You can set parameters in here via the face or through your WSM control software. And once you have the parameters set up, you would just sync it through the infrared.
Wow. That's impressive. This is an impressive set of features.
It's fun. It's and actually we have a new version that'll be coming out as well. That's going to have an extra Dante output on it. All right, and also the command option. Do you remember the command option?
No.
The command option it actually became really popular with the 3732 system. On the command option, we got the first request for this through the NFL because they wanted the reporter that was talking on the sidelines to be able to talk back to the director, the producer.
To the control room. Got it.
Right.
Yes.
So
you can steer the output.
Yeah, exactly. So we put a button on the SCAM 5200s so that when they pressed it, and you could tell the receiver what to do, they could press it and actually mute program out, so mute your analog outs, and then have a separate output that goes back to the truck.
Got it.
So they could press it and say, hey, I'm going to go over and interview number 22 over here, and then release it, and then they unmute program out, and then they can go over and do it. You can also make it so maybe you don't want them to mute the program out and have that power.
Sure.
You can have it so they just add it as a talkback back to the director or producer, so they don't have that power.
And will there be a separate set of Dante outputs that follow?
It'll be available on the Dante out. It'll be available on the analog out and on the AES output. You will be able to configure. This is the plan. You'll be able to configure which output you want it to go out of. That extra output.
I think that's going to be great, especially for all the intercoms that are Dante based now.
Yes.
And really sort of route that seamlessly.
And you'll be able to do it with the belt pack transmitter as well, which will be nice.
Fantastic.
Yeah. And We see people using it for like sound checks. When they want to talk to the monitor mixer.
Yeah, absolutely.
Instead of just doing sign language.
Yeah.
They'll, turn up the kick or whatever.
Yeah.
Yeah, and for broadcast. That'll be available first quarter probably next year. We're hoping.
Good. We should talk about latency as a spec, and then I'm going to ask you about price, Mac price, I guess.
Yes, I got to remember pricing.
Let's do latency.
Yeah, let's talk about latency. I always forget pricing. Thank God I have Tom over here, who you people can't see right now, but Tom might be able to help me on pricing if he gives me some coaching. Latency is 3 milliseconds. Whether you're coming out of the analog out or whether actually there's a 0.1 difference, but for all intent purposes, it's 3 milliseconds out of the analog or the digital output.
That's fantastic.
So yeah, that's pretty good. And we're always worried about latency, and it is something to think about. When we got a lot of pushback. I think all the manufacturers did. When we're going to digital, especially for the live sound guys, because they're pushing monitors back to the talent
and it's
singers.
all cumulative and
right. It's going through my board. Maybe I got some latency there. Of course I do. And then I'm going to go back to an analog.
My digital IEM system.
Right.
Yeah.
Right. Where is the talent going to get to a point where what's going on? Especially drummers. Right?
Yes.
And they can really start to hear that happening. Yeah. So we try to keep it as low as possible, and this seems to be working. We got it out with Beyonce and Taylor Swift and a bunch of others. Taylor Swift was really tough, but it seems to be okay with the latency side. And I think you'll see through all of us and other manufacturers that the latency will get better and better over the years.
Taylor Swift was tough because of the latency.
Yeah.
3 milliseconds was too much.
Yeah, because the cumulative was about 5 or 6. And she was starting to hear.
Yeah, you can hear. Yeah, absolutely.
Yeah. Then you have a lot of the engineers that add a little bit of reverb and try to hide it.
Right. But 3 milliseconds for film and TV, and for a lot of the sound reinforcement customers that we talk to, that seems really good. 3 milliseconds. Yeah. I've certainly seen higher.
Yeah. It seems to be working out pretty well. I've done tests with. Where I was noticing it, of course, is when I'm matching an analog with a digital.
Yeah.
So we did some tests with some broadcasters where we had a hardwired MKE2. Oops, sorry, just tapped my mic. And then a digital system, and it was interesting because at that point you could hear a little bit of the phasing going on if they were sitting right next to each other.
Yeah.
Right. So that's where it can be difficult. So you still have to be aware of it and know when you can run into trouble with it.
4K, it's approximately 4K per channel depending on transmitter choice. Okay.
Okay.
Thank you, Joe.
Thank you, Tom.
So that's 4K per channel.
Yeah. The error correction is really interesting. I think this is, when you look at digital and analog, and it's really interesting to see what we're doing different. Because when you look at an analog system, we have the companding and we have the pre-emphasis and de-emphasis. And that's interesting to really see, especially for the film guys out there. A lot of them will do that key test with analog systems and to hear how the transients are affected as it goes through the processing of an analog system.
Right.
I think the beauty of a digital system is that it basically takes the companding out of the equation. So it can handle all those different transients that are happening. So you don't get those artifacts that you can get if you're hitting a wooden block or if you have keys jingling and things of that nature. That's where I see a big difference when you go to digital, is the cleanness of that and how you can handle all these different transients regardless of what the sound source is.
Right. I think for a lot of the cart users that we have, they would love to see a 2-channel or even multi-channel DC version of this. So either of the camera variety, slot in receiver style, or where it's a single rack that runs on DC.
That would be if you're going to do something like that more portable, then it would be the EK6042, which will accept. It'll receive transmissions from the SK6000, but also from the 5212 analog transmitter. It's actually a unique receiver because you can transmit either an analog or a digital signal to the receiver. And if you're going to do a digital transmitter, then you also get rid of all the companding noise as well. And it works with the sound devices enclosure and the PSC
Great.
enclosure now as well.
So cross compatibility between this one and the 6042, you said?
Yes. Yeah, so you can take the SK6000 belt pack transmitter or handheld and transmit that to our slot-in EK6042 receiver.
Cool.
Yeah.
All right, any questions?
Yes, we have one. Is there any plan for a smaller body pack transmitter?
There is. That's a great question. Yes, in fact, we had a prototype of it that was zooming around New York a few weeks ago, and we do have a plan for one. And not sure when it's going to be out, but I did see it, and it is very small.
Can you talk about what is 2018? Can you talk about battery and battery specs and RF power?
Not right now. No.
Okay.
Not too new on the whole design stage of it.
But
so
a rechargeable system.
But it'll be a rechargeable system, most likely a removable battery is what we're predicting. Right now, we're just getting a consensus from the end users out there about what they need in a small belt pack, what kind of form factor is going to work for them.
No sharp corners.
Yeah, no sharp corners, yeah. Keep the letter openers at home. Yeah, but yeah, that's a great question, and working on that one.
Good. Anything else? No? Dave, it's been a real pleasure.
Thank you, Peter.
Thank you for taking the time.
My pleasure. Thank you, everybody, for joining us.
Thank you. And thank you, guys. Thanks to the crew. Get Your Freak On is a seminar that we're doing this Sunday.
I thought you were talking to me. Right now, here?
Let's go. Navigating the spectrum of people as a wireless mic operator and comms, too, wireless comms, with Lectrosonics Shure's XCOM. It's here at Gotham, Sunday, September 10th, 12 to 3, or it'll be online, although in person is much more fun. We'll have prizes. Yes, prizes. Anyways, video archives, gothamsound.tv. Follow us on Facebook and Twitter, and please send your ideas, questions to info@gothamsound.com. Thank you for watching. Thanks, everybody.
Thanks.